Good morning all. Welcome to mathematics class of grade 8 and this is my lecture number 2 of chapter number 12 exponents and powers. Dear children, I hope you must have understood all the concepts being taught in the previous lecture. Let us see now the topics to be covered in this lecture number 2. Let us see now the topics to be covered in this lecture number 2. First of all, dear children, we will recapitulate the concepts of lecture number 1. That is, we will revise what are exponents, what are powers, laws of exponents, and then we will move to the main topic of this lecture, that is standard form. How to represent small numbers in standard form, and then we will explore more about converting numbers from decimal notation to standard form and vice versa. Dear children, this concept, that is converting numbers from decimal notation to standard form, though you must have studied in your previous class, but we will explore more about this topic in this grade 8. Let us now recapitulate the concepts. Dear children, we have learnt about exponents and powers. So what are powers and what are exponents? Yesterday I gave few examples. Let us consider few more examples. Now if I want to multiply 3 times, then how can I write this? This can be written like this, 3 raised to the power 4. So multiplication many times is powers. This format of writing the numbers is known as powers. Now in this 3 raised to the power 4, we read it like this, 3 raised to the power 4. In this 3 is the base and this 4 is the exponent. And this exponent can be positive. Here it is positive. It can be negative also. It can be 0 also. So we have seen the difference between exponents and powers. After that, we have learned that 2 raised to the power minus 4 is equal to 1 over 2 raised to the power 4. 2 raised to the power minus 3 is equal to 1 over 2 raised to the power 3. It means when exponent is negative, to make it positive, I need to take the reciprocal of the base. This is the base, 2 is the base here, and this minus 4 is the exponent. So to make the exponent positive, what do I need to do? I just need to take the reciprocal of this base. So reciprocal of 2 is 1 over 2 raised to the power 4. Now we have generalized it, as yesterday we have seen that a raised to the power minus m is equal to 1 over a raised to the power m, and a raised to the power minus m is the multiplicative inverse of a raised to the power m. This all we have studied in the previous lecture. Now let us have a look on the laws of exponents. Now talking about the laws of exponents, the very first law we have studied is a raised to the power m into a raised to the power n. What is it equal to? A raised to the power m plus n. When base is same and they are being multiplied, exponents will get added. This is your first law. Let us talk about second law. It is a raised to the power m divided by a raised to the power n. What is it equal to? A raised to the power m minus n. Let us talk about third law. This is a raised to the power m, and further it is exponent n is also there. So these two will be multiplied and it will be equal to a raised to the power mn. Let us talk about fourth law, that is ab raised to the power m. Here this will be equal to a raised to the power m into b raised to the power m. And fifth law is a by b raised to the power m is equal to a raised to the power m divided by b raised to the power m. Sixth law which we have learnt or which we have recalled is a raised to the power 0 is equal to 1. And we have also seen that a raised to the power minus m is equal to 1 over a raised to the power m. So dear children, I hope all these concepts are clear to you as we have discussed in this previous lecture. Let us move to the main topic of this lecture number 2, that is standard form. What is this standard form? Let us take one example. Do you know, dear children, the distance of Earth from the Sun is given by this kilometers. So what is this? This is basically the distance of Earth from the Sun. Now, if I need to express this number, can I write like this? 1.496 into 10 raised to the power 8 kilometers. So, expressing the number, large numbers, or you can say small numbers, expressing the numbers in the notation where we are expressing it as a multiple of 10, as it is being multiplied by power of 10. So, expressing the numbers in such a form so that they are being multiplied by a power of 10. Now, such a form is called standard form. I am repeating it. This is basically the distance of Earth from the Sun, and this I have written in the form 1.496 into 10 raised to the power 8 kilometers. Now, what I have done, I have expressed this given number as a decimal number. This is what I have written as a decimal number. I have expressed the given number as a decimal number which is being multiplied by a power of 10. Multiplied by a power of 10. So such a number is called standard form. Let us take another example. This was example number 1. Let us take another example. The average diameter of red blood cell is given by 0.5 meters. Now, how to write this in standard form? Can I write this number as 7 over 1, 2, 3, 4, 5 and 6. So, it will be equal to 7 over 10 raised to the power 6. What is it equal to? 7 into 10 raised to the power minus 6. So, I have expressed this given number as a number which is being multiplied by a power of 10. So, this is what I have done, or I have changed this given number in standard form. Expressing the numbers in this format is known as standard form. I hope, dear children, with the help of these two examples, it is now clear to you what do you mean by a standard form. So, I am repeating, if any number can be expressed as a decimal number which is being multiplied by a power of 10, such a form of number is called standard form. Let us learn now how to convert very small numbers from decimal notation to standard form. If a number is given to you in decimal notation, you are supposed to convert the numbers into standard form. Let us see one example. I am taking one number, that is 0. I need to convert this number into standard form. Now, the method is, you are supposed to move this decimal point to the right side till you get just one digit to the left of the decimal point. You are supposed to move the decimal to the right. If I am going to move this decimal to the right hand side, I need to stop here till I get this digit. So, I will be writing this number as 2.73, and how many steps I have moved? 1, 2, 3, 4, 5, 6 and 7. So, it will be 10 raised to the power minus 7. Whenever you are moving the decimal from left to right, you are supposed to take the negative exponent. It will be a negative exponent. I am repeating it. When the decimal is you are supposed to move the decimal from left to right, you are supposed to stop till you get first digit. Like I have started moving the decimal from this point to this and then this. Likewise, I will keep on moving till I get this digit, that is 2, and I will be placing the decimal after this, that will be 2 decimal 73 into, and how many steps I have moved? 7. So it will be 10 raised to the power minus 7, as we are moving the decimal from left to right. This is the first example, first type of numbers in which you are supposed to convert the numbers into standard form. Now, what if the decimal is not at all given to you? Like it is the number I am taking 216 and these many zeros. So here, when no decimal is present, you are supposed to move the decimal from right to left till you get the last digit. Like I have started moving the decimal from this position, that is right to left I need to move, that is 1, 2. Like this I will keep on moving till I get the last digit. So it will be written as 2 decimal 16 into 10 raised to the power. How many steps I have moved? 1, 2, 3, 4, 5, 6 and 7. So it will be positive. When you are supposed to move the decimal, I am taking one more example. When you are supposed to move the decimal from left to right, I am taking the example. In this case, look at these two examples carefully now. In this case, in example number 2, you are moving the decimal from right to left till you get the last digit, and you are supposed to write the positive power of 10, positive exponent of 10. Now in this case, decimal is here and you are supposed to move this decimal from left to right. Like this I will keep on moving till I get the first digit. So it will be equal to 2 decimal 1 into 10 raised to the power minus 6. Like how many steps I have moved? 1, 2, 3, 4, 5 and 6. So it will be minus 6. When you are moving the decimal from right to left, it will be a positive exponent. When you are moving it from left to right, it will be a negative exponent. Now coming to the next topic, that is, in this topic we will be learning how to convert very small numbers from standard form into usual decimal form, or you can simply say usual form. So now we will learn how to convert the numbers from standard form to usual decimal form or usual form. In the previous examples we have learned to convert the small numbers from decimal form to standard form. Now here in this topic we will be learning how to convert numbers from standard form to usual decimal form. So let us take one example. Suppose I need to convert this number. This is given to you in standard form because it is expressed as this is expressed in decimal form, which is being multiplied by 10 raised to the power. 10 raised to the power any number multiplied by a power of 10, you should say like this. So this is being expressed in standard form. Now I need to convert it into decimal form. What should I need to do? How will I proceed in this case? This will be done in the manner that 321 over 100, this will be written into 10 raised to the power 5. As the exponent was negative, so to make it positive, I need to take the reciprocal of this base, that is 10. So I have shifted it in the denominator. Now it will be 321 over 10 raised to the power 7. Now, how can I write it in decimal form? Look at this now. This will be written as, it will be 0. So after decimal, 7 digits should be there because it is 10 raised to the power 7. So 3 are already present. So 4 zeros you will be writing like 0.1, 2, 3, 4, 5, 6 and 7. Here the exponent is 10 raised to the power 7. So after decimal, 7 digits should be there. 3 are already there. 321, 3 digits are there. So I need to write 4 zeros and 3 digits are already there. So it will be 10 raised to the power 7. So this is how I need to express standard form into decimal form. Let us take another example. That is example number 2. This is 3 decimal 52 into 10 raised to the power 5. This is being given to us in the standard form and we need to express it in usual form. So this will be written like this. It will be 3 decimal 52 into 1, 2, 3, 4 and 5. So this will be finally equal to, this will be, you can write this as 352 over 100. So these two zeros will get cancelled out with these two zeros, and what you will be getting, it will be 352 and 3 zeros will be left. So this will be your answer. This is how you need to express the standard form when we have positive exponent of 10 in the usual form. Now let us move to the topic of comparing very large and very small numbers. Dear children, suppose you want to know that sun is how many times larger than the earth. Plant cell is how much larger in size as compared to red blood cells. What is the total mass of earth and moon at the time of solar eclipse? What is the distance between sun and moon, etc.? There may be so many questions that you want to get the answers. For this, you have to divide, add, subtract. You have to divide, add, subtract the numbers in standard form. So this topic is all about comparing very large and very small numbers. Let us find the answers of few questions. Let us take first example. Diameter of sun. First example I am taking. Diameter of sun is equal to 1.4 into 10 raised to the power 9 meters. And diameter of earth is equal to 1.2756 into 10 raised to the power 7 meters. This is the diameter of sun and this is the diameter of earth. So let us find out, or let us compare these two diameters. So to compare, I need to take their ratio, that is, or I need to divide them, that is 1.4 into 10 raised to the power 9 divided by 1.2756 into 10 raised to the power 7. Now this base is same and they are being divided. Then what is the exponent law? It will be, their exponents will be subtracted. So it will be 10 raised to the power 9 minus 7 as per the law of exponent. This will remain as it is in the denominator. So what is it equal to? 1.4 into 10 raised to the power 2, that is 9 minus 7 will give you 10 raised to the power 2. So I am writing 100 here over 1.2756. So approximately, if you divide these two, you will be getting the diameter of sun is about 110 times the diameter of the earth. So what we have done, we have compared the diameter of sun and earth and they are being given to us in the standard form. So what we have done, we have taken their ratio, or we have divided them, and as this is, the base is common, so exponents will be subtracted and they are being divided. So as per the law of exponent, we will be getting 10 raised to the power 2, and after dividing you will find that it will be approximately 110. So we can say that diameter of sun is about 110 times diameter of earth. Hence, we can say that sun is 110 times larger than the earth. So I hope you have understood how to compare the numbers, very large and very small numbers. Now let us talk about addition of numbers in standard form. Suppose I am taking these two numbers 1 decimal 496 into 10 raised to the power 11. Actually, this is the distance between sun and earth. I need to add or take the total distance, and the distance between I need to subtract, and the distance between earth and moon is 3.84 into 10 raised to the power 8, and I need to take their difference. So during solar eclipse, moon comes in between earth and sun, and at what time the distance between sun and moon I need to find out. Actually, I am taking these two numbers. This is basically the distance between sun and earth. This is basically the distance between earth and moon, and I need to subtract. Here you can add or you can subtract also. In the same manner, subtraction can be done. So to add or subtract the numbers in standard form, we need to convert into numbers with same exponent. Here, try to convert this number into 10 raised to the power 8. We need to have the exponent same. We need to try to have the same exponent in both the numbers. So let us see how we will be doing it. It will be 1 decimal 496 into this. I can write like 10 raised to the power 3 into 10 raised to the power 8, and 8 plus 3 is 11. So I have written like this. As I told you that you are supposed to write or convert the numbers with same exponent. Here the minimum exponent is 10 raised to the power 8. So I have written 10 raised to the power 11 as 10 raised to the power 3 into 10 raised to the power 8 minus 3.84 into 10 raised to the power 8. Now, what is it equal to? These 3 decimal digits will get cancelled out with these 3 decimal digits, or I am writing these steps. It will be 10 raised to the power 3 into 10 raised to the power 3 into 10 raised to the power 8 minus 3.84 into 10 raised to the power 8. Using the law of exponent, base is same, exponents are being divided, so they will be subtracted. So 3 minus 3 will be 0. So 10 raised to the power 0 will be 1. So I am writing like this, into 10 raised to the power 8 minus 3.84 into 10 raised to the power 8. Now dear children, what can you find? Can you find that this 10 raised to the power 8 is common in both the numbers? So can I write like this, or can I take 10 raised to the power 8 outside, or can I write like this? 10 raised to the power 8 will be taken common, and 1496 minus 3.84 will be done. These two will be subtracted into 10 raised to the power 8 meters will be your answer. So let us see now the final answer. So dear children, this was the last step. So after taking their difference, what I can get, it will be 1492.16 into 10 raised to the power 8 meters. So if I will be shifting this till this point, that is if this decimal I am shifting it from right to left, so what will be my answer? 1 decimal 49216 into 10 raised to the power 11. Why I have written 11 here? Because 3 places I have shifted the decimal, that is 1, 2 and this 3. So it will be 1 decimal 49216 into 10 raised to the power 11 meters. Now I hope you must have understood how to subtract. the numbers given in standard form. First of all, what you are supposed to do? You are supposed to make their exponent same, like I have done in this example. In the same way, if you are supposed to add, in place of this negative sign, it will be plus sign. Rest procedure will remain same. So dear children, let us see now NCERT questions of exercise 12.2. Though I have well explained you how to convert the numbers in standard form as well as in usual form, I will be doing one part of every question. Rest parts you are supposed to do on your own. So question number 1, first part I am doing. First part is I am writing the digits. It is now 85. Now you can see this as the decimal is here. From left to right you are supposed to move till you get the first digit. So I am moving the decimal from this step like this. How many steps I am moving? Let us see now. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. So it will be 8 decimal 5 into 10 raised to the power minus 12. As we are moving the decimal from left to right, exponent will be negative. Let us talk about fifth part. It is 3186 and how many zeros we have? 7 zeros. 7. Now here there is no decimal, so we are supposed to move the decimal from right to left. As decimal is not present this side, so we need to take the decimal from the right to left. So how many places I am going to move? Let us count now. It will be 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So it will be equal to 3 decimal 186 into 10 raised to the power 10. As I have moved the decimal from right to left, so I need to take the positive exponent. So this will be your answer for first part and this will be the answer for the fifth part. So let us talk about question number 2, first part. Here, this is the number given to you. This is already given to you in standard form and you are supposed to convert this number into usual form. So let us see how you will be doing. It will be done in the manner, it will be 302 divided by 100 as the exponent is negative. So to make it positive, shift in the denominator. So it will be plus 6. Now as the base is same, powers will get added and as they are being multiplied. So it will be 302 over 10 raised to the power 8. Now after the decimal, there should be total 8 digits. 3 digits are already there in the number. So how many zeros you will be writing? 5 zeros after the decimal and these 3 digits like 0 decimal 1, 2, 3, 4, 5, 6, 7 and 8. So total how many digits I should have? 8 digits because it is 10 raised to the power 8. So this will be your answer. Like this students, you are supposed to complete all the parts. So dear children, in this lecture number 2, we have learnt how to convert very small and very large numbers into standard form and usual form. So it's time for the homework now. Homework from NCERT book you are supposed to do. That is complete question number 5 to question number 7 of exercise 12.1 because in the previous lecture we have discussed till question number 4. So you are supposed to complete question number 5 to question number 7 of exercise 12.1 and question number 1 to question number 4 of exercise 12.2 in your homework notebooks. Thank you so much.